or to cloud. Okay, I believe it's recording. Hello, everyone. Good afternoon for the people that are here and the ones on Zoom. Another lecture of CNT 4704. So today we have things to go over. We'll speak course logistics, and today we'll have an intro slide, a couple of slides that are related to the syllabus, but more in depth, and then we will start chapter 1. So a few things to go over is the announcement. I made an announcement today for the certifications. Now, most of you probably already know about this, some don't. So you might qualify for a reduced price for the certifications. And I provided the link. This was brought to me by the students in my undergrad, so I figured I'd share it with this class as well, in case the students don't know. So if you're aspiring to get any CompTIA certifications, Oracle, whether it's 8+, Network Plus, Security Plus, you have those at a reduced cost. I'm not sure the eligibility requirements, how about the details exactly, but Alexis is the person to reach out to. They have, I believe, office hours, and it's something very useful and to consider building your resume and if you plan to work in the industry. Okay, that's that. And I also have a couple of things to speak about that I wrote down. Yes, so the next thing is the financial aid assignment. So if you go to the modules tab, everyone has to complete this, as I mentioned in the first lecture. It's just a couple of questions. Please complete that, regardless if you're receiving financial aid or not. And okay, that's good. Oh, also for office hours, I haven't got assigned my location yet, my physical location, and neither the TA's office hours will start next week. And as soon as I get those, I will update them. Lastly, regarding the lecture on Monday, I have to go back and record this lecture as I announced. So if you bear with me, I'll get it out by the end of this week, Friday. And this is for the ones that are that didn't came in or didn't attend via Zoom. And I believe that's it. So we will start with our intro presentation. Okay, good to go. Okay, so today our lecture is going to be a course overview / an introduction. We spoke about the course overview in the first lecture, but today we'll go a little bit in depth. So let's start. So I have to announce this, that the lecture is being recorded, and it will be available for the students to watch. And this is typical when we use slides from outside. They have to be we have to reference them and they have to be known. So an amplified portion of the slides are coming from JF Caroz, and I believe this is coming from the book. So also another question regarding the book. The book is not required, it is optional, but our chapters are coming directly from the book. So if you have the book as an alternative, it would be great for the extra readings. So don't get scared by the analysis because that we have in this course. It's going to be basic analysis of communication networks. It might scare you a little bit. We will not do major analysis. It might be a few things. Definitely, we will use Wireshark and maybe a Cisco packet tracer. So don't be scared. We'll talk about the analysis when it comes to it, and we will have the lectures that explain everything. So the introductory of this course is in computer networking. We will speak about networks, obviously, I will give an introduction about them today. We will dive into how the architecture, the protocols, the topologies of networks, like we have mesh, bus line, star, and ring, many of them. We will speak TCP/IP, and we will have a one programming assignment about that. The TCP/IP is just a protocol, and protocol is a means of communication, and we all humans communicate in a certain way. So we'll talk about email, SMTP. Also another protocol, we'll talk about the web, HTTPS. We'll talk about Ethernet, hubs, wireless, hands. So we'll talk about physical and the software of networks. And we'll speak relatively a little bit about the security. Nothing too much, because there are other courses designated for security, but we will speak about a little bit here, especially when we speak about the protocols and how can networks be more secure. We'll also speak concepts on wireless security. Well, I'll have an intro about them today: cellular and mobile technology and wireless security. So this is the book that I'm talking about. It is the 8th edition. It's a top-down approach, and in our course we will cover networking from a top-down approach. Basically, to give you an analogy, if we're talking in a car perspective, we will analyze the car from the top to the bottom. So we'll talk cosmetic, inside of it, all the details. So that's how we are gonna, this course is gonna be structured in terms of the lectures. And the 7th editions and the 6th edition of this book is also sufficient. You do not need to get the 8th if you can get that. Online resources, if I find anything useful, such as videos, articles, I'll upload that as well. Class notes, you may take notes, that's optional. The slides will be also uploaded, and the lectures will also be uploaded, the recordings. Now this is something I wanted to speak about, because in our assignment, in detail for the programming assignment, we're gonna implement a client to server protocol. So we need to use Eustace and Eustace 3. And have any of you guys used Eustace before in your previous classes? Okay, that's good. When I was a student, we also used it for the higher graduate classes like malware analysis. And when I was a student, we already had accounts assigned to us by Eustace. So this is something for me to figure out if the accounts will be created for you guys or we have to create them. And yeah, go ahead.
They're all done.
They're automatically created.
Yeah.
Amazing. We don't have to deal with it. So yeah, they will automatically get created. Now, to use Eustace, you also need to be on the UCF Wi-Fi. If not, you have to use a UCF VPN. And for that, they use Cisco AnyConnect, and I used that before. You guys are familiar with it, right? Okay.
Yes, it's easy.
Okay, that's perfect. And then we also have a guide here to Eustace and how to use you don't need too much of to be familiar with Linux. We use a couple of terminal commands that you might need to know, like changing the location, and yeah, transfer a file, how to enable host. Let me open this very quick. Okay, so this basically talks, and this was prepared by Dr. Salamanki, I think. Yeah, so basically a guide to Eustace and the Linux command line. You can refer to that when it comes to our programming assignment. And basically, it's a server, and we use an ID and password that we have here. Also talks about connecting to Eustace while using the campus Wi-Fi, establishing a UCF VPN. It has all these things, and it gives actually visualization, which is very useful for you guys, for the ones that are not familiar with it. Going back to the slide. Oh, also there's an older version, 2019 version is also available. Okay, let me just move this. So
just a little side note, just mention like whenever you put in your password, it doesn't show, because a lot of people kind of freak out for that.
Yeah, obviously, yes. When you're writing your password on the terminal, it will not show. But once you click enter, if it's wrong, obviously it's not gonna let you in. But yes, thank you for that. So when we talk about top-down approach for this class, is basically we'll cover networks from top to down. So we'll start with the end systems, which is applications, end-to-end transport. And when we talk about end systems, what we're referring to is that devices could be our phones, laptops, tablets, devices that we use to connect to the network. And then we'll also, regarding the top-down approach, we break it to end system, and we also go to network core. It's basically the routing hooks that hooks together, which is the backbone that carries the data across the internet. And you can think of that internet service providers, ISPs, AT&T, Spectrum, big routers, and data centers. Then we'll talk about the link level protocols, TCP, IP, various protocols that we will get to throughout the semester. And we'll talk about Ethernet, so the actual connections between devices in the core, so physical as well. So we talk from a physical and a logical, which is a software perspective. And we'll talk about other interesting stuff, like I mentioned, security and wireless. Now, for the course overview, since we talked about in our last slide, we'll talk about end system, network core, and link level. Here are the main details and the modules we'll talk about, the core ones in our course. We'll talk about the transport layer, and this ensures that reliable communication between applications happens, like TCP, reliable delivery. UDP for speed, we won't talk much about it, but we'll cover it in the next slides. We'll also talk about the network layer. We want to know how the network decides a path that takes the data throughout the network, like the IP addresses, like mailing addresses for computers. The link layer, which moves data between directly connected devices, like the Ethernet or the Wi-Fi. And the physical layer, the actual hardware. And we can see a link that connects physical to physical because we are talking about actual physical. So hardware and signals, like cables, fiber optics, radio waves. Here's a quick analogy for you to understand this outside maybe of the context of or course or CS related. You can think of communication like a mailing package. So transport makes sure your package is delivered correctly, like FedEx or like FedEx tracking, yes, or Amazon, whatever you prefer. Network, it decides the route. So like the GPS, choosing the roads, which one is more efficient, which one is faster, how do we get to campus in the quickest way? Link is the short hop between neighbors, like a local street, and physical is the road itself. And when we mean physical, we talk about wires, signals, and airwaves. So that's the introductory slide. I have slides for that we will cover now in this lecture. Then after that, we'll speak about the application letters. I will go over these slides very quickly because these are just the material that we are going to aim to cover. So we'll talk about the application layers. We'll cover principles of application protocols, the World Wide Web, HTTP, electronic mail, the Internet Directory Service, DNS, similar to the Active Directory service that is the centralized hub for networks. And then we will have our socket programming assignment. And this assignment is going to be very simple. It's not going to be something too major. You won't need a lot of programming experience, and you can use any programming language that you want. And it's basically the goal of this assignment. It's used for client-server communications, like a web browser connecting to a web server or sending a message, email. We'll talk when the assignment get released. I'll talk more about it. Then we'll move to the transport layer, as I showed you with the figure. The service and principles, the connectionless transport, UDP, principles of reliable data transfer, TCP as a case study, and the congestion control. We'll move to the network layer, what's inside the router, routing principles, algorithm, hierarchical routing, IP, the internet protocol, and then internet routing with the various ones we have over there. We'll also cover link layer, local area networks. And the reason I'm talking over these is I just want to give you an idea of what we will cover as a whole, as a big picture for this class throughout the semester and how we build up to it. So we'll cover link layer, local area networks, like we introduced the introduction of LANs, the services, error detection, correction, multiple access protocols, LAN addresses, and Ethernet. Then we not only cover networks, we also cover cellular and wireless mobile technology. And this is an extension of Chapter 6, overview of smartphone technologies, iOS, Android operating system, the mobile protocol and compared to the network protocols, logical channel descriptions, encryption standards. We won't go into too deep about encryption, like the RSA, algorithms, the DSA, and all those. But we'll speak in it from a high-level idea. Mobile identifiers and local-based services as well. Next, we will speak about wireless security and network security, extension of Chapter A. What is the security? Introduction of cryptography, classical and modern cryptography, public key and its application, cellular network vulnerabilities, and security protocol. We want to understand how networks, Wi-Fi vulnerabilities, and security protocols as well. So as a summary, this is you can think of it as a introductory course, but not quite. The stuff that we talk about, some you should already know, but we will cover it. And practical, we will have a practical like hands-on with this class. No basic programming network programming. Almost you need, all of you guys, that you need to know about this and its application. Will we cover any SDN and NFB? Potentially, I will have to review the class curriculum regarding that, and if this is something that is wanted by most students, then yes, I can add it and we can make a lecture about it. That's fine. There's important concepts that you will need in this class, or you should know in the future. And with this class, trust me, there's many acronyms, so don't be frustrated. If you don't know an acronym, just Google it. Wikipedia can get you up to speed with that. Okay, so I think, yeah, that ends the intro lecture. Next, we will speak about our chapter 1. Okay. Wondering if we can use this. This is not good. We'll just download the PowerPoint. Okay, we can skip over these. Already spoke about that. Okay. So now, introduction to internet. Do any of you guys have some of these devices at the house? Smart, okay. Anyone else have any of these?
Yeah.
Okay, okay. Yeah, so basically the internet devices that are connected to the internet, they can receive and send data, also known as IoT devices. I have actually some of the devices I have. I don't have an AR, but I do have a VR. And this is just to give you an idea that we have various devices that are cool and they're connected to the internet. Okay, so we want to talk about the internet from a nuts and bolts view. When I say nuts and bolts view, does anyone understand or have a concept of what we're talking about regarding to networks? We want to simplify it. We want to make it very easy, simple. So with from a nuts and bolts view, we have a billions of. Let me just move this up. We have a billion of connected computing devices. And like I said, host end-to-end systems could be anything that we can see here: laptops, phones, various things, IoT devices. And the applications of those is web browsers, whether it's like accessing the UCF web course, video calls, games, etc. We also have packet switchers that forward the packets. And in the next, throughout this course, we'll talk about how the data gets encapsulated and how it gets broken into chunks before it gets sent out. We'll talk about routers and switches that direct network traffic by forwarding the packets. Also, we'll cover communication links, fiber, copper, radio, and satellite, transmission rate, the bandwidth, the networks itself, which is a collection of devices, routers, linked, and then managed by an organization. Whether it's an institution, enterprise, a company, they control that. Okay, the internet, a service view. Since we talked about from a nuts and bolts perspective, we want to talk from a service view, which What does the internet provide? Infrastructure that provides service to various applications, web, streaming, video, multimedia, um, emails, games, a bunch of things. And then also a use for it, I'm not sure why this, okay, also provides programming interface. Have anyone dealt with that before, programming interface, like using APIs? Have you guys used any APIs? Okay, yeah, perfect, okay. So I used a lot of APIs, like I mentioned, I'm not sure if it was for this class. We used APIs for ChatGPT. One of my works, we used ChatGPT to label our data. We tested it first manually, and we compared it to ChatGPT, and we found out that ChatGPT does excellent. We do not need to manually annotate it. Another one could be VirusTotal. Have you guys heard of that one? Okay, yeah, checking our applications because we worked on mobile applications, so we check them and to see if they're malicious or not. Yeah, so it provides a lot of things. So the internet is both physical infrastructure, nuts and bolts, and a service provider for our applications. Now, moving to protocols. We spoke about protocol, and basically a protocol is something very simple, though, in a way that we communicate. So if me and another person, we want to agree on a meeting, we have certain protocols to agree to the meeting, which is the time, the date, when and where. So specific messages sent and specific actions taken when the messages are received. Networks are the same. We need protocols for networks, computer devices rather than humans. They are governed by communications. So protocols define the format, the order of the messages sent and received among network entities, and actions taken on message transmission receipts. This is you might see as the network protocols in simple and to peer-to-peer networks. But when we speak of networks as big, we need protocols such that we become more efficient, we can scale more up because we are dealing with industry, enterprises, and institutions. So it's not only small, so it gets big. Okay, this is just an example of a human protocol and a computer protocol. I think these are the known Alice and Bob. So when they communicate, Alice sends hi, Bob sends replies back, got the time, 2 p.m. And the question for you guys are there other human protocols? Text messages, yeah, okay. So I just want you to pay attention to the line that's going down at the time, because everything is time consuming. So even with a human conversation, it's time consuming. When we move over to the network, it's also time consuming. So a protocol that we have for humans is already set by us by linguistic. For the protocol for networks, one of them is TCP. So basically a device requests something from the server responds, and then it gives you a link, and that then it gives you a file. So basically, if you are browsing an example like Cengage, a website, so you send a request, the server of the website replies to you, and then it loads up the web page, and it talks back to you. So they both require agreement on format, order, and meaning of messages. This is chapter 1. We will not be able to cover all of it today, but this is like the roadmap of it. So next we talked about the internet. We want to talk about network edge and system access networks, which is wireless networks and links. Okay, so a closer look at the internet structure. When we say network edge, is when users connect to the internet. And this could be anything like we have laptop, our phone. They're also connected to the internet, the satellites, and these are routers. They're also connected to the ISPs. ISPs are, so it's a big picture that's all connected. And then here we have enterprise networks and how they differ from mobile networks and home networks. So we scale up as based on our needs and based on the environment that we are. The hosts are the client and the server. So a client server, has anyone heard of the application AnyDesk? Okay, that's a client server example. Basically, if I have a laptop here and I want to control my desktop at home, I connect to it and I can access it from there. So example of that. And servers are often in data centers, as it's known. And yeah, that's basically an example of the devices. The ones are highlighted in red. Now, access to networks and physical media, we need those to connect the devices to the networks. We can do it wirelessly using analogs, and we can use it physically. So that's the connection between the users and internet. We use home Wi-Fi, cellular data, DSL, cable, and fiber. I will talk about those today, and I will have a table, an overview that compares among them, the benefits and the disadvantages. And we also talk about the network core, the backbone of the internet that connects different networks. Example, routers inside internet service protocol, high-speed fiber lines, and data centers that are highlighted in red. Interconnected routers. We'll talk about the difference between maybe a router and a hub, and a router and a switch, sorry, and can they be used together? Can anyone tell me what a difference between router and a switch is?
Switches operate on the like layer 2 of the OSI model, where and routers operate on layer 3, so they're actually transferring the packets to other routers for us to serve within the internet or within the.
Exactly. Yeah, so the switches work in smaller areas with LANs, and we can have multiple switches that connect to various routers that connect to the internet. So how to connect end system to edge router. And we'll speak about today residential, which is internet and Wi-Fi, and then we'll also speak about mobile, cellular, 4G and 5G. So keep in mind with that, we have our speed, the bandwidth, how fast can the data move, and it's also, it might be costly, so setup and monthly fees, and mobility, whether the user can move around, example, mobile versus wired. Now, we want to talk about DSL. What major is physical. So the DSL uses existing phone lines to provide to the internet. So for example, let's say we have a household that has a device and also has a landline, which we don't use any now in our houses, but yeah, it was there back in the old days. So the DSL, I just want you to look at the line that's being connected to here. So a DSL modem at home, which is the one in blue, connects your computer to the phone line. And then we also have a splitter. What a splitter does is separates the internet data from the voice calls. So, and then at the telephone company office, the DSLAM, also another big acronym, which stands for Digital Subscriber Line Access Multiplexer. It connects many homes to the internet, as we see the ISPs. So what it does is basically it collects signals from multiple houses and merge them into a high-speed link to the ISPs. So the connection goes from the DSLAM to the ISPs to the internet. Okay, so an analogy, you can think of DSLs like using the same road for both cars and bikes. The splitter, what it does is the internet here, and the cars are the phone calls. They are both driving on the same road, but essentially they are separated so they don't collide. And that's basically the example of using DSL, where we have our devices and the mobile landline. We also want to talk about cable-based access, and we'll get to this in chapter 6 more, but I just want to give an overview about it. And we use the frequency division multiplexing FDM, which different channels is transmitted. So a cable internet, for example, we've seen an example of the mobile landline. Here we have a TV. So cable internet uses the same coaxial cable as the TV. And then we use the FDM, which are basically different frequency bands. And this is mostly in engineering and communication. They analyze this more in detail, but are used for TV, upstream internet sending data, and downstream internet to receive the data. Unlike DSL, the cable network is shared among users in the same neighborhood, so speeds can vary with congestion. We have a lot of houses, we have a neighborhood, we have a lot of houses, and everyone is using cable. So it is used among users, but the speed can be based on the congestion and the traffic. We also want to cover hybrid fiber coax. So here what we have is a combination of fiber optics and coaxial cable. It's very quick. So fiber backbone, it's very fast and long distance, and coaxial last mile is refers like from street to homes. And it also uses the FDM. But here, different bands are used for the TP, upstream internet sending data, and downstream internet receiving data. Type of connections, they're still shared among neighbors, but more scalable than pure coax. The key point here that is like HFC's hybrid fiber coax is the modern upgrade of cable internet, mixing like fiber for speed and coax for cost effectiveness. Here's just a summary of the three that we spoke about. So we have the DSL, the cable, and the HFC, the hybrid fiber coax. The DSL is mostly copper, is used for telephone lines. The cable is coaxial TV cables, and the fiber is the backbone plus coax last mile. The connection type, it's dedicated per home, the DSL, while the cable is shared among neighbors, same as the HFCs. For the speed, for the DSLs is 24 to 52 megabits down, 3.5 to 16 megabits up, depends on the distance. The cable is high speed, but varies with neighbor congestion, as we said. The HFC is higher capacity than DSL and cable, fiber adds speeds. Limitation for the DSL, it's slow if far from central office. While it is dedicated, but it gets slow if you are very far. So speed drop heavy, local use for cable, and HFC is still shared, but fiber reduces bottlenecks. And the key point is, as we said, DHL is used for old phones, steady per user. Cable is used for TVs, speed fluctuates, and HFC is upgrade of cable and with fiber for backbone. Oh, we have a comment. Marco, yeah, I think you joined late. The lecture was not uploaded, recorded. Sorry, I forgot to hit the record button. I will upload it, record it and upload it later this week. And I believe there is a class Discord for this course, right? There should be one for each course.
I never invited one.
I haven't seen.
When I was a student, and there's a Discord server for the UCF classes, right?
Yeah.
Yeah.
And they have a bot.
Typically, the class servers are student made.
Yeah, student made, yeah.
Yeah, so I don't think anyone's made one
Yeah.
at this point.
Oh, a student made, it's
Yeah,
not made.
usually students end up making it, and use the UCF.
Okay. Okay, yeah, because I thought you enrolled by putting my last name in the course ID. Yeah, maybe someone can make it if you guys can. I'm not sure who's responsible for it. Or you can make a
Usually
group.
what most people end up doing, they'll create it and then they just share it in like the discussion area. Like promote it.
That works with me, that's fine. Also, if you guys want to use the discussion tab and discuss there, that's fine. If you want to make a group meet, I'm also fine with that. Now we want to speak about the home internet, and basically we see a bunch of things going on. We have a lot of devices, wireless devices. I'm not sure, this is supposed to be a fridge, I think, right? Fridge, okay. So the devices that we have, it could be laptops, phones, more applications. The Wi-Fi access point is the tool. It's basically an analog that connects those devices wirelessly here. And mostly right now, our cell phones are connected wirelessly, and same as the house. The router manages traffic inside the home and to the internet. And the modem links home network to ISPs like the DSL, cable, or fiber. And it's an all-in-one box. Many ISPs combine modem, router plus Wi-Fi, the ones that we see now and that we have. Okay, now we want to talk about wireless access networks, which is wireless local area networks, WLANs. So they're very small, as we know. They work with a home, office, or hotspot. They use IEEE 802.11 for the standard. It's a global Wi-Fi standard that defines how the devices connect and communicate wirelessly. It's short range, so 10 of meters, nothing crazy. Um, Respectively, we have cellular networks, 4Gs and 5Gs. These are wide area coverage, citywide, nationwide. You can think of that AT&T, T-Mobile, the ones that we use today's. And the bus connects to the cell towers. I believe, I'm not sure, they always have a competition between them. I'm not sure what I like cell phone provider is the best. I have AT&T. It does well some it does good somewhere, but some places it's not the best. So it's long range, but shared with more users. Access network, we want to speak about enterprise networks. They also enterprise networks LANs. They're used in companies, universities, and school. And typically it's done by Ethernet and Wi-Fi is combined. And they use a combination of routers, of switches, of wireless access points, and servers. So the speed for the wired internet, it's 1 gigabits per second, which is common, and then 10 plus in data centers. And the Wi-Fi is typically 100 of megabits per second. The topology, the structure is device connects to switches, and switches connect to the routers and servers. Now we'll talk about the physical media, the links. This slide introduces communication links, the physical paths that transmit bits in a network. And when we say bit here, it's the basic unit of data, 0 or 1. And the physical link is the path that carries between bits and two devices. And we have two variations. We have guided media, which is wired, and we have unguided media, which is wireless. So when we say guided, you can think of twisted pair Ethernet cables, coaxial cables, fiber optic cable. Unguided will be radio wave, satellite, Wi-Fi, and cellular. Here's a comparison among the two. We have coaxial cable. It's copper core installed layers. It's used cable TV and older broadband. It can carry data at high frequencies, but as we mentioned, if you are very far, it could be your signal is not the best. Shared medium, neighbors may share the same line. Fiber optic uses light signals instead of electricity, and is very useful, very efficient, extremely high, has high bandwidth. It's good for long distance, low signal loss. It's immune to electromagnetic interference. Nothing could change like if we have a building or something that happens, the signal will stay very strong. And it's the backbone of the internet and the modern ISPs. Now we continue with the physical media. We have wireless radio. These are wireless, no cable. It uses electromagnetic waves, flexible, and it supports mobility for our mobile phones. Limited by interference, distance, and obstacles. I think before the semester started, I took a trip to Oregon. Has anyone been to Oregon? What part?
All over.
All over?
Is Salem in Oregon?
No, there is there.
Yeah.
I went to Eugene and I think I went to Portland. But anyways, we went to a lot of places like waterfalls, and one place that we went to is like a lake river, a blue river, and it's like this cold spots, and it's very freezing over there. I think 37 Fahrenheit. So when we went there, as as you go down in the trail, your Wi-Fi signal becomes weakened. And we also have radio link types, which is terrestrial microwave point-to-point links, like building to building, wireless LANs, Wi-Fi inside homes and offices, wide area, which is cellular networks, 4G and 5G. 5G is more common now. Satellite, it's long distance coverage. I tried it when I was there, didn't do any good. Global reach, but higher delay. And then, so just to wrap up this lecture, we talked about the internet from a nuts and bolts view. Billion of devices are connected that we have, then we use daily, end system and host, packet switches, routers, switches that forward data, communication link, fiber, copper, radio, satellites. We spoke about network edge and access, and systems like DSL, cable, fiber, Wi-Fi, cellular, enterprise network, the various environments. Home, mobile, and institutional networks provide connectivity, and the network core that's interconnected routers from a network of networks, and a packet switching versus circuit switching. Actually, circuit switching we did not cover in this lecture, and it's made to be part of the next lecture. In conclusion, so we talked about protocols briefly. We did not go in detail. We will have a programming assignment for the TCP/IP, but protocols define rules for communication, message format, order, and actions, physical media, the guided coaxial fiber, and unguided radio, microwave, and satellite. So the big picture, internet is an infrastructure that enables application services, and they work hand to hand, provides communication, collaboration, entertainment, and many more. So this is it for our lecture. Basically, if you see this slide specifically, is basically what we're going to cover in the next few lectures. No, it's going to be the other one, the intro slide. We talked about. Chapter 1 or intro slide? Yeah, no, it should be. Yeah, should be here. So yeah, we will, in our next lectures, we'll talk about network core, we'll talk about the delay, how to calculate the delay, the loss, the throughout networks, protocol layers, service models, and this chapter is coming directly from the book. So if you want to do any future readings, it's going to be found in the book, but we'll also cover these in the next few lectures. So that is it for now. I will record the lecture for Monday and upload it, and I'll update my office hour location as soon as I get that. And other than that, I'll see you guys on Monday. Yeah.
Home. Manage that. Yeah. We're gonna home. Stuff in my house.
Still like, yeah.